Okay, good morning. So we have already done operations with monomials, and we've done some polynomial operations, adding and subtracting and multiplying, and today we're going to do some dividing. But before we do some polynomial division, we're going to divide a polynomial by a monomial. Remember, monomial means just one term. So just a couple little bit of notational sorts of things. We could write a division problem like this with this division bar. This line really means division. Or we could write it as, instead of writing out this whole thing, 8x squared y cubed plus 10x to the fourth, blah, blah, blah. I wrote just the first part. So we could write this thing here with a division sign, 2x squared y. Or we could write the whole thing again, blah, 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 which is right here, blah, 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 times something, in this case 2x squared y, to the negative 1 power. These three things all mean the same thing. Top thing with the division bar and the bottom thing, the denominator. Or we could write it numerator here with a division sign, denominator. Or we could write numerator here, denominator here with a negative 1 power. All that stuff means exactly the same. So the way we're going to deal with this semi-tricky looking problem is to basically just divide each of these pieces here by this. In other words, this is just going to be one monomial divided by one monomial, and we do it again, and we do it again. And you've already done monomial division, so this should be easy because it's just review. And again, as usual, we start someplace that we already know something about. All right, so we're going to divide the first term here, 8x squared y cubed, by 2x squared y. And we remember when we divide, we subtract the exponents. And when we have just coefficients, we just divide the coefficients just like we did way back in the day. So here we got 8 divided by 2, which of course is 4. And then x squared over x squared, or x squared divided by x squared. Well, that's just 1, and we don't need to write that. And we got y cubed divided by y to the first. So we got 3 y's up here, 1 y down here. When we cancel off, we're left with 2 y's in the numerator. So we got a y squared right there. And we're going to do the same trick right here. So 10 divided by 2 is 5. And x to the fourth divided by x squared, just 4 minus 2, just subtract the exponents, is x squared. And y squared divided by y to the first, or just y, of course, is just y. And here we have a minus sign, so we're going to put in the minus. And we got 20 divided by 2, of course, is 10. And x squared divided by x squared is still 1. And y squared divided by y is also still 1. So we got x, y. Easy enough, just dividing monomials by monomials repeatedly. So, time for you to do some push-ups, because a lot of you have been cooped up inside, not getting very much exercise, so here's your exercise time. So you're going to do some push-ups right here. So, as usual, pause the video right here, do this problem, and we will check back with you in just a moment. All right, hopefully your pecs are improved from doing push-ups, and your triceps too. So let's do our division here. So 15 divided by 5 is 3. X cubed divided by x is x squared. And y to the fourth divided by y squared is y squared. And then we got a minus sign. And 10 divided by 2, of course, 10 divided by 5 is just 2. X to the fourth divided by x to the first. Remember, subtract the exponents. 4 minus 1 is 3, x cubed. And we got y squared divided by y squared is just 1, so we don't write that. And lastly, we have 30 divided by 5. That's a plus sign still, plus. 30 divided by 5 is 6. X to the 8th divided by x to the first. Subtract the exponents. X to the 7th. And y to the 7th divided by y squared is y to the 5th. And this is hopefully what you have. Okay, great. Now, that's all fine and good. Oh, here it is. I had a long division problem here somewhere. But what we're really all about today is long division. So I want to quickly refresh your memory on how to do long division with numbers. Some of you may not be familiar with that or have forgotten how to do it. So whenever we have a division problem set up like this number goes on the outside, this number goes on the inside. So we're going to put 8 out here, 121 inside the house, and then we just do our division. So we ask ourselves, how many times does 8 go into 1? It doesn't. So we move over and catch the second one here. How many times does 8 go into 12? Another way to think about this is, what times 8 will get us something close to 12, but not bigger than 12? And that's the way that I want you to think about this, because that's the way we're going to do it with our polynomials in just a minute. So 8 times what will get us something close to 12, but not over 12, and clearly that number is going to be 1. So we're going to do 1 times 8 is 8. And then hopefully you remember that you're going to subtract right there. And we got 12 minus 8 is 4. Bring down the next number in line, 41, and we do the exact same thing again. 8 times what number is going to get us 41, or close to 41, without going over? And that is obviously going to be 5, so 8 times 5 will get us, 5 times 8 is 40. And we subtract, and we have 1 left over. And so we could write 15R1 for remainder 1, or we could write 15 and 1/8. 15 and 1/8. I want to give you a little bit more detail that you may not have known from back in the day. When we say 15 and 1/8, that and is really, of course, just a little plus sign, because and, of course, is plus. So 15 and 1/8 is really 15 plus 1/8. It's the same thing. So we're going to be using this stuff right here in our long division problems with polynomials. And here comes our first one. So we're going to divide that into that. And remember, this problem could have been written with a division symbol, or it could have been written as something in parentheses to the -1 power. All the same type of problem. I wrote it like this to save us a little time and a little bit of rewriting. So we're going to divide x plus 2 into this, but we're not going to look at all of x plus 2 and all of this at the same time, because that's just too much to think about. We're just going to look at the very first term here and the very first term here, and ask the same question we did just a minute ago with the numbers. And that is, x times what will get us to x squared, or at least close to x squared, without going over? And obviously, x times x will get us x squared. So we're going to put that right here, right above the x column, because we could think about this as the x squared column, the x column, the tens column, and so on, or the 10 column, the x to the 0 column, you know. So x times what makes x squared? Well, that's x. And so then we're going to do the same thing we just did with the long division. So we take this thing up here, multiply it by this stuff out here. In this case, there are two things. So x times x is x squared. We write that right there. And then we do the same thing with the 2. Distributive property really is what we're doing here. X times 2 is 2x. Hopefully we're all down with that. And again, all we did is figured out x times what makes x squared. Clearly that's x. And then we multiply that thing by these two guys over here to get that there. And then we will subtract. We just subtract piece by piece. So x squared minus x squared is no x squared, so that's done. And then we got 7x's minus 2x's, that makes 5x's. And then we have a plus 10, bring down the next thing in line. And then we go through the whole process again. X times what makes 5x? And the answer, of course, is 5. But we don't just put a 5 there, we put a positive 5, so plus 5. Because remember, we're trying to make polynomials here. So again, we take this thing here, multiply it by this stuff out here. So 5 times x is 5x. And 5 times 2 is 10. And when we subtract, we see that we have no remainder. Not that having no remainder is good or bad, it's just what it is. We could have a remainder. In this case, we don't. And in the problem you're just about to try, there's going to be no remainder either. So as always, please get yourselves ready to do some push-ups here, or at least one push-up. Please take a moment. Really do this, please. This is so important that you do this to really actually learn the stuff instead of just watching me do it. So pause the video, do the problem. All right. So hopefully you took the time to actually do that. I really do hope that you do this, and I know Miss Pender does too. it's really important that you really try these on your own. Again, it's all fine and good to watch us do push-ups, but really the time that you get a chance to get your exercises when you do it on your own. So, all right, so go through the question. So x times what makes x squared, and that is clearly x. And then we're going to multiply that by these two guys over here, so that's going to be x squared minus 4x. And you've already done the problem, so I'm just kind of going through the steps here to make sure you got it. So we're going to subtract. X squared minus x squared is nothing. Negative 7 minus negative 4. We need to be careful here. Subtracting a negative is like adding a positive. So what we really have is negative 7 plus 4x, which of course is negative 3x. Some of you may have gotten tripped up right there. That's a little bit of trickiness right there. And then we bring down the next bit, which is the 12. And then, again, we just go through the same bit of the process. X times what makes negative 3x, and of course that's minus 3. So negative 3 times x is negative 3x. And negative 3 times negative 4 is plus 12. And as we can plainly see, when we subtract something from itself, the remainder is 0. That's not our answer. Our answer is actually right here. And our answer is right up here. I forgot to put a box around that. Just like when we did the long division problem, 8 goes into 121, 15 times and an eighth, 15 and an eighth. So the answer is up here on the top. The answer is up here on the top. All right, so we're going to do the same kind of thing right down here. You'll notice that this had a coefficient of 1, this had a coefficient of 1. I thought I would just trick that up here a little bit. I just want to show you all something here because this is really, really fun. I'm going to bring along one of our friends from class. He decided to join us here at home. Yep, there's our little stink bug friend from class. He decided to join me home here. So he's crawling away. So hopefully that adds to your entertainment for the video. So anyway, so not all of these coefficients are going to be 1. In this case, we have 2. And we won't always come up with 0 as a remainder. In this case, we're going to have a remainder, and we're going to find out what that is in just a minute. Okay, same question. 2x times what makes 2x squared? Clearly, the answer is x. And x, then we multiply x by this stuff here. So x times 2x is 2x squared. And x times 3 is 3x. And then we subtract. 2x squareds minus 2x squareds are none of them. Negative 5x's minus 3x's are negative 8x's. Bring down the next thing in line. Go through the process again. 2x times what makes negative 8x, and that's going to be minus 4. And then we multiply the negative 4 times those guys. So that's negative 8x. Negative 4 times positive 3 is negative 12. And you can see that these are not the same this time, but we're still subtracting. So negative 8x's minus negative 8x's are no x's, so that's obvious. Then we have negative 13 minus a negative 12. Subtracting a negative, like adding a positive. So negative 13 plus 12 is minus 1. And so here we have our first remainder, and let's see what that looks like. So it says minus 1, so we're going to do minus 1 over that, 2x plus 3. Just like on the other side here, when we had our remainder 1, we put it over our divisor. So it's 1 divided by 8. So 1/8. Same thing here. We take our remainder, put it over our divisor. Remainder over divisor. But in this case, remember we had a little plus sign there because it was and. In this case, it's minus, so we're going to put a minus sign instead. So our answer is x minus 4 minus 1 over 2x plus 3. So, push-up time for you. So you're going to do this problem right here by yourselves. So you're going to do 3x minus 4 into 3x squared plus 2x minus 6. And as always, pause the video, do the problem. We'll check back in a minute. Okay, so we're at 14 minutes and 36 seconds, so we need to move along here a little bit. So going through the problem right here, so 3x times what makes 3x squared? That's going to be x, which gets us 3x squared. X times negative 4 is negative 4x. Subtract it. 2 minus negative 4 is 6x minus 6. 3 times 2 makes 6, so we got a plus 2. So that gets us 6x minus 8. So negative 6 minus negative 8, really plus 8, so that's going to be positive 2. So we have plus 2 over 3x minus 4. And there you have your answer. Okay. A key concept right here is 0. We can't forget the 0. So there's an importance of 0 right here. So let's illustrate the point of why 0 is important. So if I wanted to write the number 103, I would not just write 1, 3, because that's clearly 13. We need something to keep the space in the middle here between the ones column and the hundreds column or place. So we need something to hold the place of the tens place. And what we do is we put in a 0 right in there to hold the place between those two and keep them separated. So then we have all of our columns and places taken care of. We got the ones column, we got the tens column, and we got the hundreds column, all taken care of because everyone's got a number here. So we didn't just leave it as 1, 3, we wrote it as 1, 0, 3. Same concept applies to a problem like this one. So you'll notice that here we have x cubed, here we have x to the first, and here we have no x's. So what should be happening here is we should have all of our columns accounted for. So we should have an x to the third, an x to the second, an x to the first, and a x to the none, no x. And so we're missing one of our columns right here. So we need to make sure that that column is accounted for. So what we're going to do when we rewrite this problem in a long division format, we're going to make sure we include 0x squared to make sure we take care of that place value. So we're going to rewrite the problem. X minus 2 goes there. And then we're going to write x cubed, because that's there. And as we just talked about, there's a missing x squared. So we're going to write plus 0x squared. This is really important. Please don't forget the 0x squared. Got to hold that place. And then we have minus x, minus 6. And then we just go through the process. So x times what makes x cubed? It is x squared. And then we multiply. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. And now you can see why it was so important to have that right there. Because if we didn't have that there, we'd have to end up attempting to subtract an x squared from an x. Because those are the two that be lined up now. And that won't work because they're not like terms. So we want to make sure we have like terms lined up. So x cubed minus x cubed is nothing. 0x squareds minus a negative 2x squared, subtracting a negative, adding a positive. Just trying to drive that point home, obviously, because it's a place where people get tripped up. So that's a positive 2x squared. Bring down the next thing in line, that's a negative x. Go through the process again. So x times what is 2x squared, and that's clearly going to be plus 2x. Multiply 2x squared minus 4x. And we subtract, and that's going to be a nothing there, obviously. And then negative 1 minus negative 4, so negative 1 plus 4 is 3x minus 6. And then we ask ourselves, x times what makes 3x? That's clearly going to be plus 3. And we multiply, and we get 3x minus 6, and we get a remainder of 0. So there is our answer right there. Making sure we fill in the missing term. All right, so as always, you get a chance to try on your own. So you're going to do this, and you can see here that there is a missing term. It's going to be pretty obvious what it is, so please take a moment all by your lonesomes to try this problem on your own. All right, so hopefully you got it done. And so we write x plus 2, and we fill in all the stuff. X cubed plus 3x squared plus 0x plus 4, and we just go ripping right through it. So we got x squared here, so that gets us x cubed plus 2x squared, and we subtract, and that gets us 1x squared. plus 0x. And x times x makes x squared, so put a plus x. X squared plus 2x, and we subtract. 0x's minus 2x's are negative 2x's, and we bring down the plus 4. And x times negative 2 will be negative 2x. So negative 2x minus 4. That's okay. Looks like we're going to have a remainder. I'm okay with that. I don't think I expected that. Nope, I think should have had a negative 4 there, but that's okay. Remainders are nice. We like remainders. So negative 2x minus negative 2x is nothing. 4 minus negative 4 is 8. So we have plus 8 over x plus 2. And there is your answer. All right, that's a longer video than I expected, so almost 21 minutes. So we'll have an assignment for you, and hopefully this went well. And we'll talk to you in 2 classes.